My name's Simon Higgins. I've been working on smart metering and smart grid for about 3 years now. I'm going to tell you a little bit about smart grid infrastructure and look at some of the drivers behind and the reasons and the rationale for smart metering and smart grid to kick the day off. Then look at some considerations around combining both smart grid and smart metering capabilities into a single communication solution. Strangely, that's what we're looking to do, our key for ourselves, so hence the reason why. And finally, what we believe are some real key requirements around the independent solution for smart grid and smart metering. First of all, what I want to do is, before we start, just look at this chart, which actually depicts the energy consumption per capita, so per head. And you might look at the chart and think, what the hell is Iceland doing? You might not. You might know all about Iceland. But what Iceland's doing is that Iceland's making best use of its resources. It's got 5 geothermal power stations, which provide approximately 25% of the nation's energy. So there's 310,000 people in Iceland, so you can see that they use a lot per head. And so you think, well, how come they're using all this energy? Is it because it's free, and they've decided just to switch on all their panels all at the same time? Well, that's not actually the case. So, interestingly, what Iceland are doing is they're making use of their geothermal position. We've experienced that with the volcanoes and the nice dust which came across and plagued our skies. But they're making use of it to generate their energy and their heat. So 87% of their heating comes from the geothermal power stations to heat their buildings and domestic properties in Iceland. But 75% of their power actually comes from hydroelectric. So actually they're using a lot of hydroelectric to generate their power. And only 0.1% of their energy, is actually generated from fossil fuels. So I know we've seen a lot of examples, and many of you have been to other conferences, and you may have seen examples of this is North America. Look what's happening here. Look what's happening in Italy. Well, what I would say is let's just have a look at what's happening in Iceland. They're also going to be the first to roll out electric vehicles. Their president is really pushing forward, and in 2005 they started to look at the rollout of electric vehicles in the across their continent. So they're generating all this fabulous energy, but actually they've got nowhere to put it. So they're too far away from anybody to actually build cables and sell it on to anybody else. So what have they done with the energy, and why are they using so much? Well, they recognise that they've got all this abundant resource of natural energy, and so what they've done is they've encouraged businesses to come into Iceland, and some of those businesses have been accepted and welcomed by the Icelandic nation, and others have been opposed. And I guess one of those, which goes both ways, it was Alco, and that was an aluminium smelting company. So you can see, actually, what they're doing is they are using their energy, and they're using it to the best effect for their economic basis. So they are using the process to extract aluminium from its ore using electrolysis. So it needs electricity in order to do that, and they're using that abundant level of electricity. So why am I going on? Why am I rambling on about Iceland and all this resource? Well, why I'm doing it is because we're all talking about today about clean power and smart grid. Well, a lot of people think this is about reducing the amount of energy we use. Actually, Iceland's shown us that if you've got a lot of abundant power, actually you use it. So per capita, they're using a lot of energy there. So actually, when we bring on wind and we bring on to all these energies, we're actually going to be using more power rather than less. And that really does have a knock-on effect to the constraints on our network itself. So we've got a finite amount of resource in terms of the cables in the ground, and we need to use them better. Otherwise, we're going to have to replace all the cables to compensate for all this additional energy that we'll have at our disposal. Which really goes on to my next slide now, which is the crossover between smart meters and smart grid. You know, again, many of you would have heard from different conferences about the adoption of electric vehicles and ground source heat pumps and air source heat pumps, you know, and the adoption of microgen, and that's the reason why we need to you know, have smart grid in place. Well, that's true. That is true. We do need to have, you know, there will be an adoption of all these things, but we'll end up using more power rather than less. So actually we need to use it more effectively. And in order to do that, we'll need demand-side management. DEC have looked at this through ENSG, the Energy Network Strategy Group. Ofgem's looked at this through Project Discovery, and the ENA's looked at this. I've actually stolen these bullet points off of the ENA themselves. So they will need demand-side management. They've looked at the 3 ways that you can try and curb or look at demand side, or look at demand and reduce demand. You can use time of use tariffs. You can use, you know, critical peak pricing in order to try and shape demand. You can give consumers real-time information, but the one that people don't really like to talk about too much in front of consumers is that we will actually need to do demand-side management. We will need to be able to affect the load which is on the network, independent of the consumer. So they recognise that all 3 of those methods will be required in order to make the best and efficient use of the assets that we've got in the ground, the cables that connect all our homes. So when we're looking at this, what we'll need to do is we'll need to address all of these different loads, the ground source heat pumps, the microgen, the electric vehicles that we'll have in our homes, and we'll need to address those and basically shape the demand based on consumer demand. So consumers won't recognise that this is happening. It's going to be going on in the background. We'll be able to shape the demand and give the consumer still a consistent service, but we'll have to vary their service in order to make best use of those assets. And we'll need to do that through demand-side management. We'll need to address potentially millions of devices in a very short period of time. The ENA have come out with a 5-minute interval to affect the loads on the network. So that's millions of devices which need to be affected in a very short period of time. And what does that actually mean from a communications perspective? Well, it means that what we need to be able to do is we need to be able to broadcast and multicast across the network in order to be able to address those homes in a very short period of time. And so that's a key feature of any communications network which gets selected to be the ICT infrastructure for smart metering and smart grid. And so that's where I've really been sort of concentrating my efforts, looking at communications networks that can really meet the challenges that we will face in the future. So, I'm not saying it. The whole industry's saying it. I'm saying it. DEC said it, Ofgem said it, ENA's now said it. And even our new energy minister, Charles Hendry's saying it. It's all about managing demand, efficiently and effectively. We believe that in order to do that, there needs to be a single smart grid solution. It needs to be operating on dedicated spectrum. We're going to be switching things potentially off using this network, so we don't really want to be using consumer-based networks in order to be able to deliver this type of service. It needs to be very robust. It needs to have a dedicated infrastructure in order to be able to deliver this. So there's real risks and benefits. Talks about the cables themselves. Well, so did the ENA. They looked at what would be the impact of certain scenarios, and they had varying scenarios from as little as 5% take up to a take up of 100% on the LV network of ground source heat pumps and electric vehicles. So the sort of key applications that they see at the moment, they don't know what all the applications will be to use this additional energy that we're going to be able to generate, but they do know that there will be some energy there that needs to be used, and that we will use that in new and innovative ways. So they looked at it, and what's the impact of upgrading those cables to be able to compensate for that? Well, anything from 750 million to 20 billion. You know, it costs quite a lot of money to dig the cables up and replace those. So it was, again, this isn't me, this was the ENA and Imperial College which did that piece of work. So anything from those sorts of figures. So what does smart metering, specifically demand response or demand side management, provide in terms of a net benefit? Well, the net benefit that's been delivered there is anything from 480 million to 10 billion. So it's quite a substantial, some material benefit in order to be able to deliver demand response across the communications network. So in order to be able to do that, you need a universal service. You need to have a universal performance across that network to be able to deliver a service to every home, because it could be, you know, anywhere across this network where you need to be able to deliver demand response. Any home, we're going to have microgen in rural areas, we're going to have ground source heat pumps in rural areas, as well as electric vehicles predominantly in urban areas. So we need to be able to address these meters in a very short period of time. And as I mentioned before, one of the key features of the communications network is the ability to broadcast and multicast to all those homes. So a little bit on the solution that we're looking at. We're working with a company called Census. They've already got deployed 7 million endpoints in the US and North American markets, and it independently serves water, electric, and gas. We believe that water will be also a scarce resource in the future, and we'll also need to be able to control that resource. So this is all about a utility network rather than specifically for the energy networks. This is about utilities, and importantly, we'll be able to provide, you know, independently to each one of those metering points a communication service on its own dedicated channels, and also be able to deliver to the actual network itself to be able to do automation of the electricity networks, again across its own dedicated channels, but using the same infrastructure. Our belief is that you need a single communications infrastructure in order to be able to deliver the service, not two. Why build two? People are talking at the moment about delivering the service across using a cellular network to the home. Well, that's fine to deliver readings from the meters, but actually when you need to actually activate and actuate control within the home, you need to be able to do that very securely, and a dedicated infrastructure really lends itself to be able to provide that service. So finally, I said that I would mention some basic requirements. So we believe that the communications network for smart metering and smart grid should be on a dedicated infrastructure with no vested interest in the consumer. This technology is going to go into every single home throughout the country. It needs to be purpose-built, custom designed for this particular application to be able to deliver the services I spoke about. And there needs to be a single point of control, somebody for everybody to go to and say, what's happening right now, please? I'd like to understand exactly what's going on, rather than having a distributed and dysfunctional or disaggregated group of individuals looking after the communications networks. It needs to be secure. We're going to, be switching things on and off in people's homes. I'm sure I for one, wouldn't want my electric vehicle switched off by some unknown entity. So, and importantly, this communications network will also be spanning the electricity networks themselves, which are part of critical national infrastructure. And by rights, the communications network will also be part of critical national infrastructure. So it will be, it will have to abide by the Centre for Protection of National Infrastructure guidelines. It needs to be resilient, it needs to be able to adapt to change. So the communications network itself needs to be able to adapt. There's going to be things that are going to happen over time, the environment's going to change. So the communications network needs to be able to change to that adapting environment. Buildings get built, and when you start looking at a radio network, then you need to be able to adapt that radio network in order to be able to continue to provide service. The next one, universal. It needs to be as near as damn it 100% of the properties in the UK. The benefits which are drawn under the ENA are based on having density of meters and density of communication in urban and rural areas. And so we recognise that, one, the network needs to be there, it needs to be everywhere. And two, it needs to be a very simple and efficient install process. We're going to be going into everybody's home. That's going to be a challenge in itself to make sure that somebody's in, go in and actually knock on the door and ask Mrs. Meggins to let you in and change your meter. Well, it needs to work first time, and it needs to be a very simple installation process in order to do that. So once you get in, you don't actually want a repeat visit on installation, and neither do you actually want a repeat visit to maintain the communications network, upgrade the communications network. I've heard a lot about that over time, that it actually will take benefit of innovation that happens in communications over a long period of time. Well, actually there is no case to go out and replace communications. In the investment analysis, or the IA, the impact assessment, which was done by DEC, there is nothing in there that says, actually what we'll do is we'll go out and replace the communications network after X number of years. Actually, what we're looking at is a communications network which will reside there for the lifespan of these meters, which is likely to be 15 years plus. From the work that we've done, looking at the North American market, that's a 15-year lifespan on a meter. So the communications network needs to actually be around for that length of time as well. I've already mentioned, a common platform. We're already speaking to the water companies. They're very interested in gaining access to a communications network which will be able to deliver the benefits to them as well. Because as we change and shift demand, particularly on wet products within the home, then those products will change the demand which the water companies also see. So that where they currently measure leakage overnight in the wee hours of the morning, they will no longer be able to do that, because all our washing machines will be coming on and in this smart environment as we start to shape the demand and better use those assets. So they need to have more understanding about what is happening on their networks and when they need to switch their pumps on to be able to pump and deliver the water to our homes. And finally, if you're looking at a dedicated communications network, one communications network, it needs to be able to offer it on fair, reasonable and non-discriminatory terms. So the communications network needs to be offered on fair, reasonable and non-discriminatory terms. There's lots of different market participants that will need to be able to gain access to information and access to the communications network in order to be able to provide the types of services that we're talking about. So each one of those should be able to gain access, each authorised party should be able to gain access to the communications network to be able to provide those. And if we don't do that, we're not fundamentally following one of Ofgem's final, or one of Ofgem's key statements, which is promoting choice and value for consumers. So that's me. I appreciate you, and thanks very much for listening.